Hello, everyone. I'm really glad to be here. And I'm a little bit sad that we couldn't meet in person, but I hope that you'll enjoy this talk. And at some point, then we'll overcome all these problems with Corona stuff, and we'll be able to meet together at some cool conference. And but today we have what we have, so let's enjoy. So I'm sharing my screen and starting my presentation. Today we'll talk about how to build microservices with Kotlin and gRPC, as you already know, and I hope this topic will be interesting for you, even if you don't work a lot with Kotlin on backend, but even if you're an Android developer, this also could be useful for you. But we mostly talk about backend stuff. Let me introduce a little bit myself. I was introduced already, so I'll tell a little bit more about myself now. I'm also organizing some meetups and conferences in Kyiv. So when we overcome all this stuff, you're really welcome to join us in Kyiv. I also write some posts in Medium, Twitter, so you can follow me if you want, because sometimes I share some interesting stuff and updates. One more really important thing you should know about me, that I enjoy boxing. I like boxing very much, and think twice before asking tricky questions, because at some point Corona will be over and I'll find you. It was a joke, so let's begin. Today we'll talk about what's gRPC, what it is, how can we work with it, what benefits can we have from it, and what drawbacks it has. We'll also implement some simple service using gRPC, and after that we'll talk about how to improve this implementation using coroutines and all cool stuff we have in Kotlin. And after that we'll talk about actually the state of Kotlin and gRPC ecosystem. So in the very beginning, let me start from the scratch. Hopefully, if you started your career 5 years ago, 7 years ago, 10 years ago, you really had to work a lot with monolith. There weren't a lot of microservices. We have all worked with monolith. But today, we see that microservices is a huge trend, because one big monolith was decoupled to a lot of microservices. And today, almost everyone on backend, when we are doing big and interesting and cool applications, we are also working with microservices. Why do people like microservices so much? Because microservices rock. What do I mean? First of all, when we are doing microservices, we are independent from each other, because microservices are small parts of your actual application, and you can develop them independently, just define some contract between them. Also, when we are talking about microservices, it's easy to scale, because you understand that some parts of your system need more high load, part of the system needs less high load, and that's why you can make, for example, 100 instances of microservice A, but only 5 instances of microservice B. And that's why it's easier to scale. And by the way, you could scale monolith, but it's just more expensive. So scaling microservice is easier because it's smaller and it's cheaper. You also can choose the best suitable tool, because you can write your microservices in different frameworks using different programming language, different platforms. For example, at my company, we use in Scala, we also have Java, we have Python, we have Node.js, and it all works together and provides really cool product for our customers. And of course, you can develop in parallel, because if we are working about independent small parts, we can work on them in parallel. And this really helps to be more effective and to bring more value and do it quicker. And so on and so on. Actual microservices have a lot of benefits, and that's why this trend is really popular in the whole world, and all cool companies try to work with microservices. But we cannot talk only about pros. There is always a little big con or a little but. So let's talk a little bit what's the problem with microservices. So the biggest issue in changing the monolith into microservices lies in changing the communication pattern. This is not my words, actually. This word said one really smart guy called Martin Fowler. And what does it mean? It means that when we were working with monolith, it was easy for us because we had just all our functions, all our services under our hands, that we could work with them easily and call them easily. But when we are split it into a lot of microservices, we need to talk about communication. And communication is something that is really hard in microservices because we have to deal with network. It could be HTTP, TCP, or some Kafka and other stuff, but it's something that is not reliable by default. So now we have problems connected to the communication. So communication in monolith was really easy, and communication in monolith in microservices sometimes could be a real hell. So you can understand that microservices had a lot of benefits, but it also had a big pain called communication. So today we'll actually talk about the communication between microservices. What is the most common way to communicate between your microservices? I think that the most common way to do this is HTTP 1.1 and REST. And if we met somewhere in person and I will be on big stage, I'll probably ask you to raise your hand if you're doing REST and HTTP 1 today. But as far as we are not there and we're doing this event online, I just assume that almost every one of you are using HTTP 1 and REST. And actually, it's a very common pattern, and even at Wix we have it, and in some situations it's the only way to work with communication. But what's the problem we could face, and actually Wix faced some point? At Wix, we have 170 million of clients, and actually our client base increases all the time. And even Corona situation helped us to have more and more customers. And that's why we need more and more servers to handle all this stuff, because it's a lot of requests per minute, per seconds, and it's a lot of servers. And a lot of servers means a lot of money. So the more clients you have, the more servers you need to buy, and the more servers you need to buy, the more your company spends for your infrastructure, pays to Google Cloud or Amazon or Azure or any other provider. But when your company pays a lot of to infrastructure, it pays less to you. And I'm not happy with this situation. I want my company to save this cost and pay them to me, and that's why. It's not actually the only reason why we use gRPC, but it's one of the reasons which can help, which could be resolved by using the gRPC. So what does it mean? When we're switching from another RPC framework to gRPC, we can reduce our costs on infrastructure just by changing communication. So it's like minimum effort, but saving a lot of costs. So let's discover gRPC, why it could actually help us in our communication. So first of all, there is a riddle. What does gRPC stand for? As you can probably understand, gRPC is not just for random letters. It's some acronym. And for a long time, when gRPC released, it was a recursive acronym and meant gRPC remote procedure call. So gRPC means gRPC remote procedure call, which is very stupid. It was later revealed. And after that, at a company called Google, which actually released this framework, they decided that it's not true anymore. So each version of gRPC, they changed the meaning of the first library. So for the first version, it was gRPC, then it was good, green, gentle remote procedure call, so Garcia, Gambit, and so on. And I think that at some point, even maybe in 20 years, they'll just run out of words in letter G and we'll have to create new words. So just funny fact, but it's nothing to do with our topic. So let's proceed. That's about G. But what the hell is RPC? if you're working with Java and services, microservices, or even you try to communicate between different applications, you probably heard about RPC. There was a very common pattern called Corba or RMI, and actually gRPC is close to this stuff, but it's a little bit easier. So what does RPC mean? According to Wikipedia, it's a remote procedure call means when your program can call another procedure program like it's your own, like it's under your hands or somewhere, like you're working in a one big monolith, but actually it can be run on different server and somewhere different place. So remote procedure call, just you treat the function or the service or on another server as it's your own. So really cool actual stuff and really cool idea. But for a long time, it was very badly implemented. So gRPC is a really cool implementation of remote procedure call, which makes things easier and it can help you to use benefits of RPC and have less pain than it was in Corba and RMI. So how we can do this? Let's discover a little bit gRPC features. First of all, gRPC is built on top of HTTP2. You probably heard about it, but you probably haven't used it. So I'll talk a little bit about its main features. Of course, we can talk a lot about HTTP too, but it's not our topic today. So let's just talk some main points. Little bit about HTTP protocol evolution. In 91, it was HTTP 0.9. Then it was 1.0. Then it was 97 1.1. Actually, the version that almost all of us are using. And then no progress, and still no progress. Maybe they're not alive. I guess no. And suddenly, in 2015, HTTP 2 appeared. And so, of course, a joke. Of course, they had a lot of stuff to work on. They had a lot of stuff to improve, and they weren't lazy for over a decade. And they just were creating some cool stuff. But what I want to say is that we're using HTTP 1, most of us still, which is actually an outdated thing, which was created in 97. And even most of you even started your career after this and even graduated from your universities after this. And I guess that HTTP 2 is something that we really have to look at. And of course, if you investigate this topic a little bit more, you will find that there is also HTTP 3, which is going to come in, I hope, soon. So we'll probably should look into HTTP 2, because at some point we'll have HTTP 3, but when we're still at HTTP 1, it's not that cool. So this about the history a little bit. Let's talk a little bit about HTTP 2 real points, why it can help. First of all, we finally have single TCP connection. Before this, in HTTP 1, we always opened new connection when we had new requests. We could send keep alive, but we had to deal with timeouts, and it was not really convenient. So finally, we have this TCP connection open for one client, and you can use it. And when we have this one connection always opened, we can use it in bidirectional streaming. So it means we're using the one connection to send a lot of requests and to accept a lot of requests there. So bidirectional streaming could be done via HTTP 2, even without using any WebSockets. And one more cool feature for HTTP 2 is that it introduces us flow control. What does it mean? Sometimes, for example, if there are some Android developers there, you can understand that not all devices really can handle all the stuff where our servers send into them. For example, there are some tablets, mobile phones, and not really powerful computers. So It's really hard sometimes to handle all the requests. So if we're starting to spam a lot our clients can be down and our customers can be disappointed. So how to deal with the situation? There is a flow control. It's the mechanism that can help our client to communicate with server and ask them to send like a bunch of requests and then to suspend. And when our requests are handled, we will receive another bunch of requests. So it's just receiving the requests in proper pace. At proper pace, and that's why our clients are happy, are satisfied, and our customers won't leave us. So this is about HTTP2. Then gRPC also supports multiple languages. So you can, as I already told you, when you're doing microservices, you can use different programming languages, and gRPC supports it. There are a lot of languages that are supported by default officially, but you can also see a lot of like open source libraries that add additional support for some exotic languages. And even if you don't see the support for your favorite language, you can actually create it. It's not like very difficult stuff, and you can create your own implementation for gRPC for your programming language. And then finally, I think that one of the most important things is gRPC is binary. Why it's binary? First of all, because HTTP2 is a binary protocol. HTTP1 sends string via network, and HTTP2 sends bytes via network. And bytes are cheaper, of course. Another thing that in order to convert your requests and your responses to bytes, we are using Protobuf. It's interface definition language, which can help us to operate messages, requests, and responses in more convenient and object-oriented way. But under the hood, it transforms it to bytes. So, having all this stuff, I hope before Kotlin, most of you worked with Java. And Java likes gRPC. It means there is an official implementation, gRPC Java, and you can work with it. It's not ideal, but it actually can work. And I know a lot of companies using this stuff. At Wix, at some point, we find out that gRPC can help us and can solve some of our problems. So we also like gRPC, but we had a little bit problems. That we like gRPC, but we don't use in Java, we are using Scala. Scala is not supported by gRPC by default. So if you go to their official site, you won't see Scala label there. But there is library called Scala PB, open source and really cool library. It's almost released, and it's pretty stable. And we're using this for our gRPC weak stuff, and we also built some bridges and some cool things on top of that library, and our own framework even. So we are actually happy with this. But Scala is not an ideal language, and it has some problems and some unknown future. And we started to think about Kotlin, that we need Kotlin, and we need somehow to integrate it with our existing framework. So we tried to ask ourselves, is it possible to have Kotlin gRPC in our Wix infrastructure? And that's how this talk appeared and my investigation started. So we finally discovered gRPC, and we can go further. I already told you that gRPC is binary. So I mean that messages that you send from server to client are bytes. In order to achieve this, gRPC uses protocol buffers. So let's talk a little bit more about what it is. Protocol buffers, or Protobuf, is Google's language-neutral platform, mechanism for serializing structured data. So think of it like it's XML or JSON, but smaller, faster, and simpler. What do you mean? What do I mean? First of all, you have to define some protofile using pseudo language. So we see that here is a service greeter, and it has some RPC call called say hello. This call has hello request and returns hello reply. Hello request and hello reply are just messages. So you can see that message is analog of class or data structure, something like this. And our hello request has some field called name, and our hello reply has also a string field called message. So you just define this proto file, and then we are compiling it using some plugins. And finally, you have classes or some structures into your favorite language. So if you're using, for example, gRPC Java, it will be compiled into classes in Java. So let's summarize a little bit about Protobuf. First of all, if we are talking about Java, Scala, Kotlin, it will be type safe. Because you will operate with these messages as with data classes, with classes in Kotlin or Java. And as far as we have static typing in Kotlin, we'll have no problem there. So if you try to do some mistake, you'll have compile time error. Then, because of this, you won't have any schema violations. Because not only your messages are classes, but also your services will be compiled to classes into your language. And serialization, deserialization is fast because we're working with bytes. And it's backward compatible because in all messages we have fields, and these fields are optional. So it means that you can easily add new fields, and you can easily deprecate old fields. So it will be done very easy. But the main problem is lack of human readability. It means that when you try to, if you somehow try to debug this and try to catch the message which was sent from your server to the client, you'll see only bytes. And if you can't read bytes, you're in trouble. But actually, I don't think it's a real problem. And I don't think that you need much of this stuff. There are also a lot of converters to JSON, so on server client side, you can easily convert it to some like human readable representation and show it. So I think I'm talking a lot. Let's do a little bit of coding. Let's implement some simple servers. As I already told you, I'm a big fan of Star Wars, and I decided that I need a Death Star. I want to be this tiny little Death Star in order to destroy all the universe. When I usually do this talk at some conferences or meetups, I do it online, and people are programming with me and they can play the game in production. But having online, we can focus more on the implementation stuff and less on that just production stuff. So today we'll talk more about code. So let's discuss the first case. The first case is when user joins our application. So first of all, user goes to our Death Star, and then in order to paint all the planets, Death Star goes to our planet service and see all the planets that we have in the universe. Then we receive these planets from our planet service and send them to our client in order to paint the universe. So when user joins, first of all, he sees, or he or she sees this universe with all the planets. And then we subscribe user to our logs. It means when something happened, when one user joins, another user joins, when something happened with our solar system and someone destroyed some planet or another planet was born, we'll see this in our log window. And we also will subscribe for our leaderboard in order to see the score of other users and in order to compete. So you can see that this is a streaming request because our users subscribe for it, and then asynchronously we will receive updates in logs and on leaderboard. Another thing is when user joins and he wants to delete some planet or destroy some planet. So in order to destroy, our user goes to the star service, and the star service goes to planet service. So in order to delete destroyed planet, so our client destroyed some planet, and we say to our planet service that this planet is no longer alive. And our planet service is a little bit cheater. It generates new planet and answers to the star service that yes, this planet was destroyed, but here is a new planet. So please notify the user and repaint it. Also, during all this stuff, during when planet was destroyed, when new planet was born, everything is logged in logs, and scores table is updated because if user destroyed some planet, he achieves some goals and he has some score. And as far as we remember, when user joined our application, he or she subscribed to logs and scores, we have to notify the user. And of course, notify user with new planet and repaint everything. So let's implement it. First of all, we have to write this proto file and define the contract. We see that we have this destar service and we have method destroy. And this method we have request and response. We see that we have additional word stream. It means that destroy method is bidirectional streaming. So it's not like a single request, but we'll have a lot of requests, and all requests will be synchronously received from our client, and we'll asynchronously send him or her our streams of planets. And here is our messages. Planets. It just repeated means list of planets, and destroy planet request is with username, planet ID, and weight. So then a little bit magic happened, and we see this class is generated from our proto file. So then we code a little bit more, and we can see the implementation. First of all, when user calls method destroy, it means that we want to subscribe to our planet service. So we add our client to our listeners, and then we go to planet stub in order to get all the planets. And when we get all the planets, and we notify our user to repaint everything. And after that, we need to return stream observer because if we remember, our destroy method is bidirectional streaming. So it's not a single request, it's a stream of requests and stream of responses. That's why we have to return stream, and let's look inside of the stream. In this stream, we have override method on next. So we are passing a callback. And this callback, what do we do? We remove the planet using like planet stub. Then we update scores because planet was removed and we have to update score. Then we log that planet was destroyed. Then we generate new planet, and after new planet was generated, we are using another callback and log that new planet was generated and notify all our users that new planet was generated and you have to repaint the universe. So, well done. We're actually done with this destroy method. Let's look into it a little bit more. And there's something that really makes me sad or something really not that good. Yes, it is. I really don't like this shape. This ugly shape has a name. This code callback hell. What the problem is this? Because all the time we are trying to use the result from previous operation, we have to pass the callback. Whereas there is the only way to work with gRPC in Java is stream observer, and we have to work with callbacks, and which is the only way in Java. And it's sad. Actually, if it was the only way to work with gRPC, I would like to give up with it and say that I'll pay more money to Amazon or Google Cloud, but I will never use this stuff. But actually, we have a solution. So here comes gRPC and Coroutines. First question, why don't we use futures? Why do we work with these stream observers if you can like somehow write this into futures? And gRPC actually supports this. So using futures, we can see that we still have this, what we see that we firstly add our client to list of observers, so in order to be notified later. And then using some Kotlin stuff, you can launch a coroutine and do it with await method. So when we are doing planet get all planets, we're not using the callback, we're just calling method await, and then we're using this all planets in order to notify our user. So, and then we again have to return this stream observer because we're still with gRPC Java. But inside the stream observer, what do we have? We again have this launch. So we create a coroutine, and then we remove planet, we add score, we destroy planet, then we generate a new planet, and the result of generation is put into variable. Then we log that new planet was generated. After that, we get all planets from our universe. And you can see that the result of this operation is put into another variable, and we can use it here. So what you can see that we flattened actually the inside this callback. So our method destroy now looks a little bit more flattened. So in this stream observer, we just see the business logic. So we remove planet, then we add score, we destroy, we log everything, and we see that this logic is straight. We don't have a mess here. We have only important stuff. But so it's not that bad, but actually we still have to work with stream observer. And here comes another part. So it's like, I guess for a year and a half ago, actually I stopped on this point, and there were no other solution to work with gRPC and Kotlin and Coroutines. So I created some other bridge tweaks, and we did some dirty hacks in order to work with Coroutines. But then another cool things appeared. So who are we? Let's proceed. And discuss a little bit about Kotlin developers. So who are we? We're Kotlin developers, and what do we want? We want to use channels. Why do we have to work with the ugly stream observers and to work with callbacks if we can actually do this communications between different coroutines using channels? And there is a way. We just need a new hero. We need a new hero who will implement this. And first hero is gRPC Kotlin. So it's a library that you can use, and it helps us to generate additional stuff on top of these proto files. And we are not only compiled to Java classes, but we also compiled to Kotlin classes and to Kotlin some bridges. So let's use this library. We added the dependency and improve a little bit our code. So what do we see? We see that we have this method destroy. We receive requests, we choose receive channel, and we have to return receive channel of planets. So we do the same stuff. We create channel, we add our channel, like our client, to the listener, and we have to return this channel. And inside this, we launch a coroutine. And what do? We send our client all the planets in order to paint them. And then we, instead of working with stream observer, we are working with our receive channel, and we are working with it as it is for loop. So we're working with channel as it is list of requests. So it's done asynchronously and lazily, not lazily, but just asynchronously. But we work with it as it is simple loop, straightforward. So what do? We remove planet, we add score, we destroy planet, generate new planet, log, and then notify all the users. So what we can see is that we don't have any callbacks here. We have coroutines and we have this straightforward business logic. And I really like this shape. It's just only business logic shape, no mess here. And it's really cool. But wait a minute. I just showed you only one hero, but there is another hero called Protobuf. Actually, it's I guess these libraries were developed at the same time by different people, and they actually reached almost the same idea, but there are some differences between these two libraries. Actually, what we can see is that two things changed. First of all, we don't return this send channel. So we don't return channel, but we just have it as a parameter here. So we just difference in generation, and that's why we don't need to return it, because we don't return it in the signature. The inside of the method is the same, so API is pretty clear and pretty the same as it was in gRPC Kotlin. But Quota Plus has a little bit more about. And because using Quota Plus, you also can do some other generators on top of proto files. So, and I even like this more. So you can choose between these two libraries. And usually, when I had this talk at the other conferences, I stopped at the point because it was like the end, and then we moved to another topics. But finally, we have some good news. On April 16th, Google announced official support of Kotlin and gRPC, finally, and we have gRPC Kotlin official library. So let's a little bit improve our demo. And actually, my demo is on GitHub and is already updated to this library. So what changed? Actually, there are a few things changed. We have flows instead of channels, which is like the more correct way to work with coroutines. And that's why we add this, not channel. And what do we do? Emits and collect. So it's like the few things that changed when I used this library for the first time. And then I compiled it and found that it's a trap. I got a lot of exceptions. So what if I see here? I see that I'm using flow, but actually my code was a little bit problematic because I had to work with like multiplayer game, and I had to notify users from different coroutines, and they can't use flow because you cannot emit flow from different coroutines. So there is a solution. We can use channel flow in order to create channel under the hood. So we have this channel flow, and instead of emit, we again use send, and that's all. I updated this, and again, I found another exception, which means that I'm trying to send to the channel which was closed. And in order to avoid this, you can just wait close at the end of your channel flow, and actually it will work, and you can enjoy this. So I have a little bit time, and we can talk a little bit more about Kotlin libraries for gRPC and coroutines. When I first started working with this, I thought that I'll have this cool robot that can save your life in every difficult situation. But it was not true, because we had these guys who can't even shot anyone in 9 episodes. But we have what we have, and we have to work with this. So first library that I thought was gRPC Kotlin, and there are two things that were really bad for me, and I cannot introduce it to my colleagues because it's 0.0.2, and there was a note that says that it's prototype, it's bad, it's something that is not reliable, so PRs are welcome, but don't use me. And I was a little bit sad because I wanted to try it, but it was difficult for me to propagate this library to my colleagues. But then, after some time, after some talk, some investigation, some updates, we had 0.1.2 version, which is really good state. And actually, at some point, this talk, my talk and my demo of this talk was fully written on this gRPC Kotlin stuff, and we worked for many people in production, and I was really proud of this. So this library is pretty stable and easy, so you can use it. Another library is Crota Plus. A year ago, I guess even more, it's like a year and a half ago, it was very like not really ready, but now it has logo, it has like channel, and it has a lot of cool stuff inside of this, and even you can not only use it for using gRPC and Kotlin, but you can also update it, upgrade it, and you can put more into your protofiles and into conversion of your protofiles into Kotlin classes. So you can even customize it better. So if you want to play more with proto generation stuff, you can work with Crota Plus. And of course, official Google's gRPC Kotlin library, which is really fresh, but you can give it a try because it's official. And actually, I guess in some point it will be like the best way to work with gRPC and Kotlin, and it will have all the benefits from previous two libraries. So here are the useful links that you can use in order to dig more into gRPC, even if you're working with gRPC and Java, if you want to go reactive, if you just want to look into into the way of compiling Protobuf. And my demo, and another link is more about performance gRPC versus REST and HTTP1 in order to understand what benefits can you have from gRPC. So like a year ago, when I talked about this topic, I always thought that I hope someday we'll have a stable Kotlin support. But I think that I'm really proud to say that today we have a stable Kotlin support for gRPC Kotlin, because we even have an official support from Google and official library. I can say that my demo is already migrated to that library, and you can look into this even more. Now it's time to summarize. First of all, use gRPC for effective communications. I think it's clear. Then gRPC plus Kotlin can be used today. I think that I proved this. And gRPC plus Kotlin make things easier because when we have this cool coroutine stuff, I think it's more convenient than to work with coroutines than to work with like simple features. And waiting for releases and flows. I mean that when flows won't be in that experimental state and we'll be able to use them in production, strongly in production. And feel free to contribute because most of the things are open source, and you know that open source lives from contribution. And the last topic is don't use gRPC. What do I mean? That don't use it when you don't need it. Please read carefully how can it help you, and after that, don't use it if you don't really need it, if it won't help you, because at some point it can even do worse. And the last thing that I want to say thank you. There are some people who helped me with my presentation, who like introduced me some ideas, and who actually these two guys developed this cool libraries called gRPC, Kotlin, and Crota Plus. And these friends of mine, they helped me with my presentation to make my slides not that ugly. And of course, my lovely George Lucas, who invented Star Wars and who inspired me to do this presentation in Star Wars style. And of course, thank you for listening to me, thank you for participating in these online conferences, and thank you for listening to my talk. I think we ran out of time. So, but if you have some questions, I will be really happy to answer it. I guess we have like 1 minute for this. So let me exit. And what I can see here. So yeah, I see one question. Then is it possible to integrate gRPC Kotlin plus Spring Boot? I think, unfortunately, I guess that the Pivotal team, now VMware, worked on this stuff because I talked to the guys who were responsible for it. Because when I first started to do this demo, I really wanted to work with Spring, but then I found out that Spring is like has this hard-coded REST stuff, and it's really hard to integrate gRPC there. So there is a way to do so, but it has a lot of dirty hacks. So I don't recommend you at the point, but I think that at some point they'll do better support. But if you want to think about it more, you can ask me and I can contact some persons from VMware who are responsible for this stuff. Unfortunately, I'm not a really deep expert in mobile, so I can't say exactly how to manage the connection, but I think that it does the same stuff in server. So I think I should stop sharing my screen. So, and in order to do some like hacks to, you can write some, how to say it, interceptors in order to intercept your requests and responses, and to do some additional logic, to do some error handling, and so on. And I think we ran out of time. Thank you for participating in this thing, and you're really welcome to ask me questions in our Slack channel and in Kotlin Lang channel, and I'll be happy to answer all this stuff. Thank you.